To answer this question, let's look at the physiological differences in between hemoglobin and myoglobin. So showing here is an oxygen binding curve for both myoglobin and hemoglobin. On the y-axis, you have oxygen saturation measured from 0 to 100%, and on the x-axis, you have the oxygen partial pressure measured in millimeter mercury. So judging from the shape of the curve alone, we can see that myoglobin has a much higher affinity towards oxygen than hemoglobin, as it is saturated with oxygen at around 60 millimeter mercury. Now, in the tissue, when the oxygen level is lower at 20 millimeter, myoglobin is still 82% saturated. So this means it binds tightly to oxygen, releasing about 16% of oxygen. In other words, myoglobin is a good molecule for oxygen storage in muscles. And guess what? A sperm whale can dive for almost 1.5 hours underwater because it has a lot of myoglobin. Now, how about hemoglobin? Hemoglobin has a sigmoidal curve for its oxygen binding because it acts cooperatively in binding oxygen. So what does it mean? It means that the binding of the first oxygen onto the first subunit will promote the binding of a second oxygen to the second subunit and so on. So for hemoglobin, it needs a high oxygen level, which is about 100 millimeter mercury in the lungs to be fully saturated, while in the tissues, it releases most oxygen, which is around 78%, because it binds loosely to the oxygen. So in other words, hemoglobin is an efficient oxygen transporter in our body.